Welcome to our exploration of Snowflake's innovative architecture. In this introduction, we'll examine how Snowflake revolutionized data warehousing by separating storage and compute resources. This means your data is stored independently from the processing power used to analyze it. Storage holds the data persistently, while compute provides the temporary power to run queries. This allows for independent scaling and cost efficiency. You can scale compute resources up for intensive tasks and down when idle, paying only for what you use. As of 2025, Snowflake is a leading cloud-based data warehousing platform with over 9,000 customers, dominating the data analytics space with its innovative decoupled architecture. Snowflake's storage layer holds data in a compressed columnar format in cloud storage like Amazon S3, Azure Blob Storage, or Google Cloud Storage. This is persistent and automatically replicated. Data persistence means it's always available and replicated across multiple locations for durability. Key features include time travel for point-in-time queries, allowing you to query historical data states. Zero-copy cloning creates instant data copies for testing or development without duplicating storage costs. Robust security features include end-to-end encryption, ensuring data protection and regulatory compliance. In Snowflake's architecture, compute is managed through virtual warehouses. These are auto-scaling clusters of compute resources designed to process queries efficiently. Unlike traditional systems, you can start, stop, or resize these warehouses on demand, providing flexibility for varying workloads. Virtual warehouses scale automatically. As demand increases, more compute resources are added to handle the load, and they scale down when less power is needed. This on-demand scaling ensures optimal performance without over-provisioning. For high concurrency, multi-cluster warehouses come into play. These consist of multiple clusters that can operate simultaneously, automatically distributing workloads across them. This allows Snowflake to handle thousands of concurrent queries without performance degradation. The ephemeral nature of compute resources means they are only active when needed, unlike the persistent storage layer, which remains always available. This separation enables significant cost savings, as you only pay for compute when it's in use. As shown in these diagrams, compute resources in virtual warehouses connect to the storage layer through the service layer, processing data without moving it. This architecture supports diverse workloads from business intelligence to ETL processing. Storage is always accessible and persistent, holding your data securely in the cloud. In contrast, compute resources like virtual warehouses are ephemeral, meaning they can be started and stopped on demand. When a query runs, a virtual warehouse attaches directly to the data. The data doesn't move from storage, but the compute power comes to the data, enabling efficient processing. This approach eliminates data silos by keeping data centralized while allowing flexible compute access. It supports diverse workloads such as data lakes and real-time analytics. One major benefit is cost savings of up to 90% over traditional warehouses, achieved through pay-per-use compute instead of fixed provisioning. Different storage configurations can be used with compute, as shown in this diagram. Virtual warehouses integrate data from multiple sources efficiently. The ephemeral nature of compute is illustrated by its lifecycle states, from pending to running and eventually terminated. The decoupled architecture brings significant benefits in scalability and cost efficiency. Storage and compute can scale independently, allowing you to adjust compute resources for intensive tasks while keeping storage constant. For example, during ETL processes, you can scale compute up, increasing costs temporarily, but storage remains stable and affordable. This elastic model uses usage-based pricing, pay per second for compute and per terabyte for storage, unlike fixed provision systems that waste resources when idle. A real-world example is Walmart, which reduced costs by 40% using Snowflake's decoupled architecture for their retail analytics. Snowflake has integrated advanced AI features like Snowflake Cortex for predictive analytics, enabling users to run machine learning models directly on data without moving it. Hybrid tables combine transactional and analytical workloads in a single table, supporting ACID compliance for operational data while maintaining analytical performance. Snowflake now supports hybrid cloud deployments across AWS, Azure, and Google Cloud with seamless data sharing via SnowGrid. These enhancements reflect Snowflake's shift toward becoming an end-to-end data platform beyond just warehousing. AI-driven analytics are trending, with tools like Snowpark enabling Python and Java code execution directly in Snowflake. Snowflake is committed to carbon-neutral operations with features like automatic resource optimization. The separation model is influencing competitors, and the platform is expected to grow at 20-25% CAGR. Walmart leverages Snowflake for retail analytics, processing billions of transactions daily. During peak seasons like Black Friday, they scale up virtual warehouses for increased compute power without changing their storage setup. Adobe utilizes Snowflake's virtual warehouses for real-time customer segmentation. During marketing campaigns, compute resources auto-scale to handle 10 times the normal workload, while storage remains constant. These examples demonstrate significant cost savings, improved scalability, and operational agility. Experts praise the model's simplicity and efficiency in handling diverse workloads.